So while that first video was loading, I did write out the roadmap I was kind of talking about before. Okay, so this is just a little dimensional analysis conversion roadmap for whenever grams, moles, atoms, and more molecules, things like that are involved. So you can see at the center where I put a little heart is the mole. So that's the unit that kind of connects everything. Right now we've really just been talking about this side here with grams and this side over here with number of atoms and molecules or formula units, depending on what kind of substance you're dealing with. At the top you can see where I've related it to volume. That has to do with gases, which we can talk about later when we talk about more specifically gases. But with the gases, since all the particles are so spread out, Avogadro was able to connect that in 1 mole of any gas, no matter what the gas is, there's 22.4 liters for volume. So he connected number of moles of particles with the volume of the sample. But here on this side of the chart, you can see at the top I have number of atoms and it has a few arrows pointing to it, and at the bottom I have number of molecules or formula units. So this really depends on if you have a pure element, you're going to go straight from number of moles to atoms. I do have an asterisk there because remember there are some diatomic elements. Okay, there are 7 diatomic elements that exist in nature, not as atoms, but as molecules. So for example, oxygen. Pure oxygen exists as O2 more than it does as O. So oxygen and any other diatomic element would be an exception where you would go from a compound then to atoms. So the compound is typically any substance that has more than 1 atom in it. It can be an ionic compound or it could be a molecular compound, which is why down here I've put molecules and formula units. If you have a covalent compound, you're dealing with molecules. If you have an ionic compound, you are dealing with formula units. Okay, so this is a little roadmap. I posted it over the summer on our AP Classroom, but I can post it to the new AP Classroom for us. And you can, of course, go from molecules or formula units to number of atoms of the substance by multiplying by however many atoms you have per 1 molecule of that substance. Okay, so this next example is converting grams to atoms. So we've done grams to molecules, now we'll do grams to atoms. Here we want to know how many hydrogen atoms there are within a 56 gram sample of water. So here we have water. It is a compound, not an element that we can find on the periodic table. So first we're starting with grams. To get to atoms, ultimately we have to first go through moles. So the first thing we are going to do is convert from grams to moles using molar mass. Because we want to cancel out grams and end up with moles, we're going to have 1 mole in the numerator and the molar mass of H2O in grams in the denominator. So multiply by 1 mole, divide by 18.02 grams. Now that we have moles, we can either consider going to number of atoms or number of molecules / formula units. We're going to go with the latter, molecules / formula units, because H2O is not an element. It's not a pure element. It has 2 elements in it and is most definitely a molecular compound. So I'm going to first go to molecules. In 1 mole of H2O, there are 6.022 times 10 to the 23rd molecules of H2O. So it's just like a dozen. In 1 dozen, you have 12 whatever. In 1 mole, you have 6.02 times 10 to 23 whatever. Okay, so we put mole in the denominator in order to cancel out so that we end up with molecules. Have we answered our question yet? Not quite. We want to know hydrogen atoms. So, hydrogen atoms, in order to go from molecules to atoms, we have to look at the chemical formula for water. How many hydrogen atoms are there in 1 molecule of water? In order to tell that, we're looking at the subscript. We have 2 atoms of hydrogen in 1 water molecule. So we are going to multiply by 2 hydrogen atoms over 1 molecule. so that cancels out molecules, so that we end up with a unit of hydrogen atoms. So if we plug this into the calculator, 56 times 1 divided by 18.02 times Avogadro's number divided by 1 times 2 divided by 1, we find out that there are 3.7 times 10 to the 24 atoms of hydrogen in this 56 gram sample of water. Okay, so that concludes our 1.1 notes section. I believe tomorrow in class we'll be working on a 1.1 practice worksheet where you get to go through some practice problems during class. And for homework, I do have some notes for you to do with the textbook, just to help you kind of pull out the important information. And I only do this at the beginning of the year because I know throughout the year you're kind of getting more homework and stuff. So eventually I'll give you more guided notes, but I think reading notes helps a little bit. It's not the best, but after notes it can kind of help to solidify what we've gone over and everything in the notes, okay? So let me know if you have any questions.